This is Geometry, Unit 4, Day 9. We're going to prove triangles are congruent, and we're going to be using angle side angle and angle angle side. We're doing the actual proofs for these. So to do any proof, what we talk about all year is you got to start with the given information. Recognize that angle G and B are congruent. So those are already marked in your picture. Notice that angle side CB is parallel with side GA. Those are already labeled. They have the arrows that tell you that they are parallel to each other. Now you need to come up with a plan to prove the triangle's congruent. Well, anytime we see parallel lines, we need to look for zigzags. And in this case, we would have these two angles congruent to each other. Those are called alternate interior angles. So now we have two A's in one triangle matching two A's with another. The next question is going to be, what is the third bit of information that we need to know that we can guarantee support? And that would be that this middle side is the same in both triangles. They both have a CA, a 2-ticker down to a no-ticker. In this case, it's AC, a 2-ticker down to a no-ticker. They both share that same length, so they're both the same. They're both off the 2-ticker, and they're both 2 A's with an S on the outside. It's called the excluded angle. Well, in this case, it's the excluded side. So we're going to start with angle G congruent to angle B. CB is parallel to GA. That's our given information. So the next thing we recognize is if we have two lines parallel, then I knew that angle BCA, B to C to A, this 2-ticker, was congruent to angle GAC. If two lines are parallel, then you got to name that type of angle. What makes the zigzag? Alternate interior angles are congruent. We know that for sure. Anytime you have that zigzag following your parallel lines, then you know you have alternate interior angles. The third bit of information is our reflexive side. The one triangle goes from C to A. The other triangle goes from A to C. Reflexive property of congruence. They're the same side for both triangles. It's one line that represents two triangle sides. That's reflexive property. Now we have triangle GCA is congruent to triangle BAC. And they're congruent. If you take up and notice, you have two A's and you have the side that's not connected to those A's. You have two A's and you have the side that's not connected to those two. Angle, angle, side congruence. That proves the two triangles congruent. In this, we're noticing that what we're trying to prove is triangle MJN, this big triangle with NLM. Another big triangle. They're overlapping with each other. So I would suggest to try to redraw those triangles. Okay, so those are your two separate triangles. We know for sure that angle JMN is congruent to LNM. That would be over here. We also know that JNM is congruent to triangle LMN. Is there anything else that we know for sure? That's two bits of information. We know that we have two A's in one triangle congruent to two A's in another. The question is, do we have more information we know for sure? Do we have a midpoint? Not for this picture. Do we share a side called the reflexive property? And the answer is yes. They share this side here is in both of those triangles. It's NM for the one triangle and MN for the other. So we're going to say that angle JMN is congruent, not triangle, but angle. Did I say that right? Angle JMN is congruent to angle LNM. Angle JNM is congruent to angle LMN. That's part of our given. That's what we know for sure. NM from our first triangle, two ticker to a one ticker, needs to go in the same pattern as that two ticker, one ticker. So that's why the letters have to switch. That's not always the case, but that's happened twice now. That's called the reflexive property of congruence. Now we have our two A's and a side. That side happens to be in between those two A's. So we're going to say that triangle MJN is congruent to NLM. Now we know those triangles are congruent because of two A's with the S in between. For the second page, we're trying to prove that triangle AED, that triangle, with triangle BEC, that triangle. These two triangles are not overlapping, so it's not really necessary to redraw it unless you would like to. We know for sure that AE is congruent to BE, and angle ADE, that one in here, is congruent to BCE. So that's only 2 bits of information. What is a third bit of information that you know for sure by looking at the picture? We know that both triangles have a corner at point E, and point E is the intersection of 2 straight lines. So we have vertical angles here. So now we have 2 angles and the side not in between that's making them congruent. So we're going to talk about side AE being congruent to side BE. That's part of our given. And we also have angle ADE congruent to angle BCE. That's part of our given. We have another part, angle AED is congruent to angle BEC. What would be our reason for why those 2 angles were congruent? If we have vertical angles, then they are congruent. Remember, the then portion has to always match what our statement says. Angles are congruent. Then they meaning angles, the vertical angles, then they are congruent. We have 2 angles and the side not in between those angles. So we have triangle AED is congruent to triangle BEC because of angle, angle, side. 2 angles and the side that is not between them. Here's our last one. Looking at our picture, there's no marks on it, so we got to take our given information and figure out what our marks might be. ST is perpendicular to TW. ST is right there. TW, they're perpendicular, so we can put a box in the corner. VW is perpendicular to WT. That's going to put a box in this corner. We also know that angle VTW, that's this one here, is congruent to SWT. So now I have 2 angles in each triangle congruent, because we always know right angles are congruent. I have the reflexive property also. That's the side that's shared. If you go from the right angle down to the 2 ticker, that's TW. If you go from the right angle to the 2 ticker, that's WT. So we're going to start with our given information that ST is perpendicular to TW. And we're also going to say that VW is perpendicular to WT. That comes from our given information. What does it mean to be perpendicular? If you have perpendicular lines, then we know that angle STW, angle VWT, we know that they are right angles. How do we know they're right angles? If 2 lines are perpendicular, then they form right angles. Okay, so we know that for sure. Now, I also know that STW has to be congruent to angle VWT. If right angles, then congruent angles. So not only are they right angles, I now know, and for the first time I've stated it, that they are congruent. I also have TW congruent to WT. We've talked about why we're changing the order of the letters. It's because of how they go on the triangle. From a 90 degrees to the two ticker, from the 90 degrees to the two ticker. They're going in opposite directions. We need to label them oppositely. And that's called reflexive property of congruence. When they share the same side, when the two triangles are touching and they share the same side, it's called the reflexive property. We know that angle VTW is congruent to angle SWT. That was part of our given. So now we have a pair of angles the same, we have a pair of sides the same, and now we have another pair of angles the same. We could have put that up at the given, not a problem, and we would have had 5 steps. But instead of slamming it up here and putting it before we really needed it, I wrote it down here. We know that triangle STW is congruent to triangle VWT. And that's called angle side angle congruence.